Hello DoK Valencia, my name is Veda Talakad. I'm a member of technical staff at Portworx by Pure Storage. Joining me in presenting this to you are Adi and Aditya.
Hola, DoK Valencia. I'm Adi Kulkarni. I'm a member of technical staff at Portworx by Pure Storage.
Hello DoK. My name is Aditya Dani. I also work for Portworx by Pure Storage, and from all of us, we'd like to thank DoK for giving us this opportunity.
We want to share how we solve one of the pain points or problems for a Kubernetes cluster administrator, the problem of accidental namespace or persistent volume deletions. So let's talk about this not so trivial problem. If you did a simple Google search for keywords like undo namespace delete or undo persistent volume delete, look at the results. It returns you roughly 19k hits. The sheer magnitude of the result speaks for the prevalence of this critical problem that impacts business. Most of the systems do plan for some sort of recovery, such as scheduled backups or snapshots. However, schedules usually create point-in-time copy of the data every couple of hours or maybe at a maximum frequency of every hour. This is far from adequate to have your applications run backup instantaneously in such a scenario because they don't have the most recent data. You might have configured a DR, which allows you to get your applications back up and running quickly, but not all deployments justify the cost of having a DR. So what if you could create your persistent volume such that your volume has most recent copy of the data, most recent data just before deletes, or better yet, your namespace or your applications could come back such that your application picks up the data where you left off before the release and starts to run instantaneously. We did that. Now Adi would explain you how exactly we did that. Thank you. Over to you, Adi.
To solve this, we present Volume TrashCan, a way to recover accidentally deleted PVCs. When a PVC is deleted, we capture the PVC state and the data right before the delete operation. We then store this captured state in the TrashCan. The state is retained in the TrashCan for a user-defined duration of time, after which it is permanently deleted. This allows the user to basically go back in time and restore the state back on the volume. The resurrected volume has the same labels and volume options along with the same data as the volume had when it was deleted. From the application perspective, it looks as if the accidental delete never happened. Now let's take a closer look at how we achieve this. When a delete request comes in for a volume, we take a snapshot of the volume and preserve the name of the PVC and the namespace along with the current data state of the volume. This snapshot is annotated with the in-TrashCan label, which causes the snapshot to be handed over to a TrashCan manager. The TrashCan manager is responsible to permanently delete this snapshot when the user-defined time to live timer expires. Using a snapshot gives read-only protection to the volume when it is staged in the TrashCan. Now, storage providers can choose to not use snapshots, but instead tier out the volume to a cold storage, which will free up the capacity on the hot tier. The time to live for the snapshot handed over to the TrashCan manager is controlled via CRD parameter TrashCan minutes. This CRD parameter can be applied to a storage class like in this example. We can also use this parameter on the namespace, which will cause all the PVCs created in the namespace to borrow the time to live setting. The TrashCan manager monitors the cluster TrashCan, and whenever a volume reaches its expiry, performs a delete of the staged snapshot. While the volume is staged in the TrashCan, if a user realizes that it was deleted by mistake and wants to resurrect the volume, all they have to do is annotate their persistent volume claim with a restore from TrashCan and scale up their application. The scale up of an application results in a volume create operation on the storage provider. The storage provider, on the presence of the restore from TrashCan annotation on PVC, triggers a search and restore call to the TrashCan manager. The TrashCan is searched for a snapshot which matches the PVC name and the namespace name. Upon a successful find of such a snapshot, it is used to perform a restore. Now, in cases where multiple snapshots are found, the latest deleted snapshot is treated as the correct one to restore from. once the volume data has been restored from the snapshot is deleted. Here is an example of how restore from TrashCan notation is applied on a persistent volume claim CRD. Now some of you might say, hey Addy, all this is good, but I don't want to do this on per PVC, especially if I want to restore an entire namespace. Then I would say, good point, and that brings me to how to restore accidentally delete a namespace. As a namespace restore could be a long-running operation than just a single volume resurrection, we need to introduce namespace states. A namespace in its life cycle can be in 3 different states. 1. Ready state. In this state, all volume creates do end up creating a new volume. 2. In TrashCan state. In this state, the namespace does not exist and hence no new volume create operations will be acted on. 3. In restore state. Now in this state, all the new volume create operations will first try and resurrect the volume from TrashCan. If no entry is found in the TrashCan, a new empty volume will be created. Also, the TrashCan manager will pause permanent delete of state snapshots belonging to this namespace until the namespace transitions out of in restore state. Here is an example on how restore from TrashCan annotation is applied to namespace CRD, which puts the namespace in the in restore state. This namespace can be moved to ready state by later editing the namespace CRD and removing the restore from TrashCan annotation. Now I will have Aditya walk us through a demo of a namespace resurrect after it was accidentally deleted. Over to you, Aditya.
Thanks, Adi. In our demo, we are going to be using a Jenkins application. As you can see, there is a Jenkins deployment along with the service, and it's using a persistent volume claim. This persistent volume claim is using a storage class called Jenkins-storage. I want to show you this storage class and the specific parameters that we have set on it, especially the parameter TrashCan minutes. This is currently set to 10 minutes, which means that if this PV gets deleted, it will be stored in the TrashCan for the next 10 minutes and can be recovered from the TrashCan. I would like to show you the Jenkins UI here. We have configured a couple of builds that would be running on this Jenkins. And now we are going to go ahead and blow away this namespace. We'll delete this namespace by running the kubectl delete ns command, and that's going to clean up everything, even the persistent volume claims. Now I want you to take a note of the PV name here. We're going to search for this PV name in the Portworx CLI. So if you list the volumes on Portworx CLI, you wouldn't see anything. But if you list the volumes in the TrashCan, you see the same PV name reference. So it's there in the TrashCan and it can be restored from the TrashCan. Let's check if the Jenkins UI is still accessible, and as expected, it's gone because there is no deployment, no service from that namespace. So let's try to resurrect the namespace. So I'm going to create the namespace with an extra annotation. That annotation is restore from TrashCan and it's set to true. This annotation essentially tells the storage provider that whenever a new PV request comes in, it needs to first search its TrashCan and find if there is a volume that needs to be restored from the TrashCan before creating a new one. I'm going to show you the PVC and the Jenkins app or deployment specs. So the PVC spec is exactly the same as it was before, and it's using the Jenkins storage class, and the deployment is a regular Jenkins deployment. We're going to apply both these specs, and the storage provider will go ahead and actually resurrect the PVC and the volume and its data from the TrashCan. Okay, so let's see if our PVC has been created, and it has been created. Let's go ahead and check on the Portworx CLI and see if you see a new volume. First of all, you don't see anything in the TrashCan, which means that we have restored from the TrashCan, and you now see an actual volume that is available, and that's our Jenkins volume. Let's check if the Jenkins app and the pods are up and running. I'm just going to do a kubectl get all, and you can see that the Jenkins service is up, the pods are up and running. Let's go ahead and check the UI. I'm going to log into the Jenkins UI with the admin credentials, and boom, there it is. All my builds are still there, my data is still there, and we have successfully resurrected the namespace and the Jenkins app from the TrashCan. Okay, so what's next from here? We've proven that a common concept of TrashCan can be applied to cloud native workflows in Kubernetes. We would like to extend that and probably hook on to the PV deletion and creation lifecycle. So whenever a PV gets deleted, we invoke a CSI snapshot. Or when a PV create is being invoked, we detect that it needs to be restored from a trash can and we invoke the CSI snapshot restore. In this way, this solution can be extended to any CSI storage provider, and the community will also benefit from it. Secondly, we can also apply the same trash can concept to the CRs itself, so that the users don't have to keep a track of the YAML files of their PVCs and their deployments, and we can apply the same concept of trash can minutes, wherein we will ensure that these CRs are kept in Kubernetes etcd until the trash can minutes have expired. I hope you liked our demo and our PV trash can concept. If you have any more questions, please do reach out to us. Thank you.